So in this video, we're going to actually apply two concepts. We're going to talk about basically want to use a sinking fund to actually get us to an annuity in the end. So we're going to establish the sinking fund first, figure out how much money we need to create the sinking fund. And then once we have the sinking fund created, we're going to use that to actually figure out how much we're going to pay ourselves in an annuity. So an ordinary annuity is earning 6.25 compounded annually and is structured so that a person makes equal annual deposits into their account for 25 years and then withdraws 20 equal annual payments of 30,000, reducing the balance to zero. I want to know how much must be deposited annually to accumulate enough money to provide these future payments. So I need to know how much am I going to deposit now into this account. So that's the present value I'm looking for. So in this particular case, I want to go and establish the present value to make $30,000 payments in the future, or to get my $30,000 payments in the future. So I know that the present value of my money is equal to my payments times 1 minus 1 plus my periodic interest rate, raised to the negative n, and divide that by I. In this particular case, here's what has to happen. I know that these payments that I'm going to make to myself in the end is going to be 30,000. I'm going to make 20 of those equal annual payments eventually. So my n here, I'm going to make 20 of those. So for this particular problem, we already know the PMT is 30,000. And we also know that the 1 minus 1 plus, to figure out I here, my periodic interest rate, I'm going to take R, which is here. My R is equal to 0.0625. I'm going to divide it by how often I'm compounding annually. So my M is equal to 1. So I is equal to, remember, R over M. R 0.0625 divided by 1, which is just 0.0625. So this will just be 0.0625 raised to the negative n. And so again, remember my n, I'm going to withdraw 20 equal payments. So that's how many of these annual payments I'm making. So it'll be a negative 20 all over 0.0625. So when I calculate this, I'm going to calculate this part first back here. So I'm going to do 1 plus 0.0625, which is just 1.0625. And I'm going to raise that to the negative 20th power. I get 0.297454967. Remember, I want to carry as much as I can in my calculator. I'm going to do 1 minus that. I get 0.70254540328. I'm going to go ahead and divide that by 0.0625. I get 11.244072053. I want to use all those numbers. Remember, keep all those decimals. Then I'm going to go ahead and multiply that by 30,000. And in my account, in order to make this work, in order to actually have this amount, to make those withdrawals, I'm going to need to start with, or at least have, $337,221.62. So when I count, this is actually equal to $337,221.62. So the present value of my money is going to be worth that in order to make this happen. And now that I know I need that amount here, I know that I need this amount right here. I need to find out how much each payment needs to be to have a future value of this amount. And our payment formula for future value is equal to the payment, which is the future value, times my I over 1 plus I raised to the n minus 1. So here, when I plug in what I know that this future value has to be 337,221.62 times I. We already said our I was 0.0625 still. Times 1 plus 0.0625. But this time, I'm going to be making those payments for this to get to that particular future value for 25 years. So I'm going to be making those payments now for 25 years minus 1. So when I calculate again, I'll calculate this bottom part first. So it'll be 1 plus 0.0625 raised to the 25th power and subtract 1. And I get 3.552222364. Keep all those numbers behind the decimal. I'll do 0.0625 divided by that number. And I get 0.01759469193. And I'll multiply that by my the present value that I had to find up here. So multiplying that by 337,221.62, I get a final value or a payment value equal to, so I have to have, my payments have to be equal to $5,933.29. Now, the next part of this says, I want to find out how much total interest was earned during the 45-year process. It says to find the interest, we need to calculate the total money withdrew. Well, if I'm making $30,000 withdrawals for 20 years, you've made $30,000 withdrawals, $30,000 withdrawals for 20 years. You've withdrawn $600,000. And we deposited, though, in our deposits, we've made this $5,933.29 deposit for 25 years. It's always deposited there. So we'll take that and we'll multiply that by 25, and we get this value here. So again, we've taken our deposits. We only had 5933.29. We did that for 25 years. That's how much we deposited, and that's equal to 148,332.25. So this is all we've done, $148,332.25. So much we've actually deposited into the account. So that means that in order to get to the 600,000, the rest had to be interest. So we'll just take the difference between those two values, 600,000 minus 148,332.25, and I get the interest is equal to 451,667.75. So $451,667.75 was deposited in interest for this particular problem.